guys are working on.
Great. Let's thank Stefan one more time.
Thanks.
Thank you. And now we get to welcome a scholar whose work on implicit interaction has been really influential for the work that we're currently doing here in Stockholm. So from Cornell Tech, welcome Wendy.
Hi, everyone. So I'm actually an interaction designer and early enough interaction designer that my degree is in something completely different, which is mechanical engineering. I now am a professor at Cornell Tech in New York City. So I was a little worried when we were just looking at the talk titles that maybe Auntie and I would talk about the same thing. And of course, one of the really delightful things is if it's been curated so well, it's almost diametrically different. So, so I'm going to be talking about design in the age of AI. And I call it Beyond Brains and Beauty because I think when people talk about design, a lot of times they think, oh, it's your job to make something look nice. And then when they think about AI, I think it's like, oh, it's something that's smart. And what I want to talk about is the use of design in AI for designing interaction. One of the reasons why I'm really focused on interaction is because I think it's a really interesting and tough problem. And this has been acknowledged since the very early ages of artificial intelligence. This is a really wonderful thing, a quote from Hans Moravec. It's known more generally as Moravec's paradox, where Moravec pointed out that it's comparatively easy to make computers exhibit adult-level performance on intelligence tests or playing checkers or chess, Go. And it is difficult or impossible to give them the skills of a one-year-old when it comes to perception, mobility, and then I would just add on to that interaction. So I would suggest that interaction can be the next grand challenge of AI, like one of the really tough, interesting problems to take on, and that this challenge demands like a re-examination of our methods and the ways that we go about designing things. So I'm going to show you some videos of the kind of work that my lab does in the space of human-robot interactions and autonomous vehicle interactions, just to kind of show you some of these methods that we're proposing. This title is actually, you can tell, a play on the word, the Mechanical Turk. So for those of you who know your history of AI, Mechanical Turk refers to a box that was popular in the early ages of automata, where there was a machine that basically would play chess with you. And of course, one of the reasons why it's famous is that it was a fraud, that there was actually, they would hide like tiny expert chess players inside the box and have them move things around. And so the reason why Amazon's Mechanical Turk is named after that, it's this artificial intelligence. When we're doing these kinds of things, like it looks kind of mundane. It's just people interacting with your robot furniture. But what we're doing is really unusual in the space of human-computer interaction, human-robot interaction, because what we're doing is co-constructing the interaction with the participants. As the name suggests, there's actually a person on the other side of a camera, actually, that can see what's going on in the room and is actually controlling the robot. And we actually have to have that person in there, not because it's hard to move around in the space, but because actually creating contingent interaction is still beyond, what we can easily do with machines. And so we actually are counting on the person in the other room to look at the signals that people are giving off and then try to, first engage with that person and then disengage 2 minutes later. So it's not a usability study. It's not a controlled study. The goal is actually to generate the whole range and elicit the whole range of behaviors that we can expect from people. And so in the space of interaction studies, it's unusual because we're not looking at for the mode, what's normal or what's most common, but at the whole span of what people do. So the one person that's sitting there freaking out, that's still very interesting to us because when we actually are designing AI systems, every single kind of reaction is going to be important to deal with, not just the ones that are most common. And we think this kind of research is really important because it's hypothesis forming. It's interesting and important discovery research. And that gives us a feeling for what we should be equipping our future robots to be noticing and modeling, and then figuring out what to do. Here's another example of a study we ran, which is a field experiment with a robotic trash barrel.
Right behind you. Don't come any closer. Oh, look at that. Don't come any closer. No closer. Okay. We don't have any garbage.
Okay? Are you okay? This is over here. Here you go.
So if you're a human-robot interaction person, looking at this video actually points out all sorts of things that are really interesting and even disturbing. One of the things that's really common in the HRI is this idea of the H model, that you can actually generalize how people are going to interact with the machine from human-human interaction. And there are some places where it breaks down, but that's the predominant model for interaction. Well, the way that people interact with the garbage can is really not like the way they interact with the human. One thing is that when human servers come around or busboys come around and they are collecting trash, you thank them. But when the garbage can comes around, people actually expect to be thanked and acknowledged when they put trash in. And in fact, sometimes when we were running our experiment and the person who's controlling the robot couldn't see that someone had put garbage in, people were really insulted when we interviewed them. They were really angry about it. And one of the reasons why this is happening is actually revealed in that little bit of footage where you saw the child trying to bait the garbage can across the room with garbage. The model that people have is that the garbage can wants to eat the trash. And it's obviously not something that comes from any sort of biological imperative. It's clearly a garbage can. It doesn't actually want to eat anything. And yet, the predominant way that everyone's thinking about it is like it's going to eat trash. And you can see later on that with that interpretation that some of the things that people are doing, like whistling and waving garbage, like people are actually thinking about it like it's food. And so that's the way that people interact with garbage. And with that knowledge, it can be really interesting. But I think absent doing that experiment, the idea that people would do this would seem crazy. Another thing that's really important is looking at the way that people both define and enforce social norms. So you can see that when the women kind of came up, when the garbage can came up behind women who were saying they didn't want to interact, it's a meta moment because they're interacting to say that they don't want to interact, right? They're like, and so they signal that by not turning themselves around. They're talking over their shoulder instead of turning towards the robot, which is what they would do if they were actually going to engage. But then they continue to engage, and they say, like, don't come any closer, don't come any closer. So they're engaging to say we're not going to engage. And they say, we don't have any garbage. So they're actually pointing out what the signal is for what governs whether you should be interacting or not. We also had a lot of clips where people seem to be kicking the garbage can. We're like, oh my gosh, they're mad, they're kicking the garbage can. But upon closer inspection, they were actually pushing the garbage can. And what happened was the garbage can was getting too close and people were pushing it basically to where it belonged, you know, for proper proxemic interaction. So there's all these things that we do as people, not to like just expect people to mind read norms, but actually to help indicate what the norms are and to train one another how we should interact. And when people give those signals off to machines, and if you know to look for them, you can actually define what you would want from a learning system. I'm going to show this final clip of the existing work, which is looking at human interaction between pedestrians and autonomous cars. This is known as the ghost driver experiment, and it's been taken up by many people in the automotive industry. So as was alluded to earlier, my earlier work was looking at implicit interactions, and you can see all these sort of implicit interactions people are giving off and actually looking for from the car to determine when they should come or go. So there was never an incidence where people were talking to the car or gesturing at the car about who's going to come or who's going to go. They're always looking for other lower level signals because they're doing other things. They're walking down the road, talking on the phone, interacting with their friends. So really understanding and being able to respond to peripheral signals are really, really important. For us, this kind of, the fact that looking at how pedestrians interact with cars was always really obvious, but the really challenging thing was figuring out how to run some sort of experiment so that we could really get at that question. And this kind of, we saw a prank on YouTube where a person was dressed in a car seat costume and going through drive-thrus and scaring people. And we're just like, that's how we're going to do it. And so this gets to something that I think is not obvious, but one of the central challenges to designing interactions for the future is overcoming the limitations of the present. And you have to figure out ways that you can actually pretend to have the technology that you want to have in the future in order to understand how people are going to respond to that in future, so you can actually design things that anticipate how people are going to react. So there's not just this cat and mouse game, but you actually have a chance to run little trials and try different things, like basically sketch behavior, but do that kind of sketching that all designers do. This is particularly important because we're realizing, as we move into the age where we start to see like real automation coming online, that there isn't really a future where automation is so perfect and so great that you're not going to have people involved. That's kind of the central thesis of David Mendel's Our Robot Ourselves. He actually goes through all these case studies of all these systems that were supposed to be autonomous and how much human interaction is really involved in making these things work and operate. Actually, this kind of idea that the interaction is a really important aspect of kind of automation goes back to the beginning of the word robotics. Just that term comes from this play, Rossum's Universal Robotics, that was written by a Czech playwright. And in this play, they actually had human actors, of course, dressed up like robots and interacting with people. And there's some level of this which is just convenience, but it's also kind of a way to have this conversation by having theater and having people dress up about what might happen and what the big issues are. So theater can be a way of kind of surfacing tensions and also kind of inspiring inspiration. And so that's something that we as designers might do, like think a little bit about how theater is involved in what we're doing. There is history in HCI and AI about kind of using theater and theater techniques. One of the classic works in natural language processing is this piece. It's not titled clearly. It's an empirical methodology for writing user-friendly natural language computer applications, but this is known as the classic Wizard of Oz paper. This is the paper where they talk about having a person on the other end talk to people and using that, as a way of generating the trees of what on the graphs of what natural language should look like, so they can actually bootstrap actual AI-based natural language processing. Another thing that I look to as an inspiration is the old Apple Knowledge Navigator video, which kind of showed how a person is interacting with an agent and kind of set the context and like the uses that are happening. And this is also kind of a piece of theater, with a setting and actors, but that gives you a really clear feeling for how that might unfold and what the value proposition might be. In HCI specifically, and at that intersection with AI, there's Microsoft Research's Lumiere project, which is the thing that led infamously to the Clippy. But in this project, they actually had people watching other people trying to do different desktop tasks, and then the people who were behind the screen would actually offer suggestions and advice. And because Eric Horvitz, who was running this project, was a Bayesian AI researcher, he used that to kind of build models of like what aspects of the interaction best predicted people's need for help. And then one of the big problems with Clippy was that the giant models that were used to do this prediction and smart response were actually kind of not in the product version of the product. Finally, another thing that's an inspiration is these kind of field studies. This is, for example, done by Kanda. So in HRI, he actually deployed a small robot in a mall setting, and one of these papers is really famous for being the paper which discovered that children will bully robots. There's some echoes here of the stuff that Barry pointed out is in Jalopnik that people are going to do to game autonomous cars. So yes, people will actually troll, and different bully and do different things to test technology so they can understand what the ranges are for the interaction, and that's something that should be expected and designed around. So doing field experiments is one of the ways that you find out what those things are going to be. So simulations can help us anticipate how people are going to behave in various design futures. One of the really wonderful things about working in the automotive space is that it's a field where people really take simulations seriously. Sometimes in HCI, people act like doing simulation is fraudulent. And they don't really appreciate how valuable it is as a tool, whereas in automotive, everyone does theater because it's super dangerous and risks human lives if you don't do it otherwise. So at Stanford, where it was before, this is the kind of our theater. We have a whole car inside of a 270-degree screen, and it's a really elaborate setup for an audience member of one who sits in the driver's seat. And that person has, all these projections around them, and also even little displays in the instrument panel and the side mirrors. And we use that to understand how people are going to interact with vehicles in the future. People are often focused on this idea that we're going to de-skill drivers, we're going to take jobs away. But as designers, we can actually pick interesting problems. And one of the things that we really focused on is how you can design shared control with automation. So you can make the shared control more attractive than like non-shared automation. We're also really interested in the emotional experience of autonomous driving, and also opportunities for learning and adaptation in the cars of tomorrow. So thinking about how those interactions can develop. One of the big findings that we had in this lab is this, associated with this video. And so this is 2015, and there's actually some research that obviously precedes this from flight automation. But basically, people become incredibly sleepy when they're supposed to be supervising automation. The study we ran, we actually had, was a within-subject study. We had the same people either watching a video, reading passages on an iPad, or in the third session, their task for a whole drive, they were told to supervise the car and do nothing else. And we obviously randomized the order. Afterwards, we went through the video and coded when people were exhibiting sleepy behavior, like closing their eyes for more than 5 seconds. And you can see that when people are watching a video or reading passages, hardly anyone is closing their eyes or getting sleepy. But when they were supposed to be supervising the car, this is out of 48 participants, like half are passing out and falling asleep. So it's not just that people get bored. It's like literally the task of supervising automation causes sleepiness. And so, this actually points out something interesting, that giving people something else to do, not necessarily looking at an iPad, would make it so that people would be more engaged and be more awake if you needed people to intervene. So far, we've actually seen people doing the kind of dead experiment where you either give them like driving to do or supervising to do. And we haven't considered the huge space of possible alternatives, and this kind of points at what we might be able to do. So if you think about the theater of the car, it helps us understand how people are going to behave, respond, and feel. One of the things that's really important is just to show people who work in the automotive industry videos of what this transition to and from automation looks like. Oops. So, as HAI researchers, we care about the human experience. Interestingly enough, I told you we were talking with people who do simulation experiments all the time. Very few of those people actually collected video of what it's like for the participants when they do these transitions. And you can see that even when people successfully make a transition, it's a terrible experience. It causes a lot of fear. One of the things that we can do when we notice that is actually use this data to use some of the off-the-shelf emotion recognition things and actually point out, you can actually see when people have high arousal at that point of transition, and then you can also see flaws with the current state of technology. This thing suggests that this guy is simultaneously feeling joy, anger, and a high degree of contempt, when it's really nothing but arousal. So this tells you that something in this technology is useful for discerning emotional state, and that the emotional states that are learned off of people watching ads don't map well to how people feel in the car. Maybe more radically, we've been doing this kind of experiment on the road. We actually set up an on-the-road driving simulator by instrumenting the car so we can see all the things that are going on. We simulate an autonomous car by just setting up a partition so you can't see the person who's actually driving a car, and putting a prop, which is a steering wheel, in front of the person and saying, pretend that you're in an autonomous car. And here's some video that we collected from a study where we did this. I have difficulty triggering video.
How did the dive go?
Oh, it's pretty amazing.
Go, Otto.
Oh. I guess the computer is pretty cautious, which is pretty awesome. There's a number of obstacles that I could have imagined being pretty troublesome for a computer car. It seemed to navigate through them all. A flock of people on the side of the road on this really small street,
Okay.
construction and like traffic and all these different situations where it just basically did the right thing. Yeah, it was a much better driver than most humans today.
So how did the ride go in general terms?
I was impressed. It went very well.
Did you feel nervous at any point?
I did. There was a construction site that we went past. There was a construction vehicle, and the guy was waving for me to move. I sat there like a retard, like staring at the thing. I didn't like wave to the guy or anything. I just sat there. So I was like, I really hope the car does something smart. So the car backed up, and then the guy made more hand signals.
Did you trust the vehicle?
I don't know. I just don't fully trust a car to drive on its own. Even though I had no bad experiences with this car, it just seems strange to me still that a car can drive itself.
We will now turn on the autonomous control, and the car will now greet you. Car, please say hello. Did you notice the car say hello?
I did.
What was it like?
It was an engine roar.
Okay. Did it make you feel uncomfortable or hurt you?
No, I thought it was very friendly.
Was it what you had imagined?
It was what I imagined. It was smooth, cautious, but normal driving experience. Kind of what makes it cool. I think I was surprised how much I trusted it. Even from the beginning when it said hello, that one thing like gave it enough personality for me to trust it. It made me feel like even though it wasn't a human, it wasn't of malicious intent.
It just was driving carefully, slowly. Actually, it reminded me of like a driving school instructor.
Was this pattern of driving okay with you?
Oh, it was ideal. I could definitely own one of these. How do I buy one? Do you think in 10 years?
Okay, so some of the things I want to point out. One of the things that people talk all the time about is trust and automation. And usually what they mean in trust and automation is people's estimation of the capability of the system. You can see when we asked this person here about his trust in the autonomous car, he was talking about whether the car had malicious intent towards him. We actually base our trust not just on whether someone is dangerous or whether they're capable, but how they feel about us. And so a simple thing like the car saying hello or not changes people's feelings of trust. And you can see if this is a person's job to take over and then the car says hello, that might actually decrease the chance that the person will take over because it's their friend. It doesn't mean anything ill by them. So you can see that when you actually take the things that we have as constructs as academics and go out into the real world, that you can actually see these constructs like literally break in front of our eyes. One of the other interesting things about this experiment is it raised all sorts of issues that we didn't know were going to matter, like the situation where there was a construction site going on, and the driver was waving at the person feels like super stressed. So she's not responsible for driving the car. She can see the tape on the steering wheel. She knows she's not literally able to drive the car, but she felt responsible for the car moving out of the way, backing up, which is not like actually a life-threatening thing, but just an aspect of being a good road citizen is kind of cooperating with making sure that road traffic can go on. And that person felt super stressed about not being able to be a responsible citizen. So when people are in autonomous cars, it's not just about whether they're afraid for their own personal life, but they're concerned about the car representing them as a member of society and thinking about whether they're able to do their job as members of society while they're sitting in that seat inside the car. And these are things that nobody was really talking about, but are actually critically important for adoption. So earlier, Auntie was in some ways arguing for designers to embrace math. And I would say that one of the things I would like to encourage designers to embrace is theater, improvisation. Going to Shakespeare, all the world is stage, and in this stage, designers are building the sets, they're scripting the interactions, and then maybe most importantly for AI, they're collecting the data. If you want advanced data and to be able to recognize something that's happening that's not happening yet in the world, you actually have to do a lot to stage all sorts of things to get the data so that you can even develop that algorithm. And that's something that we as designers are really well poised to do. This diagram is actually from my PhD student, Nick Martolaro's thesis, and he just successfully defended, so he's now Dr. Martolaro. And in his thesis, he argues for this idea of us designing what he calls a need-finding machine, which is the boundary object that negotiates the interaction between the designer and the person. So for the purposes of the interaction, the person thinks of themselves as interacting with the object, but the designer has instrumented the object and put it into a context so that we can understand the overall interaction. And in this way, it's a way of the designer interacting indirectly with the person. And actually, to go back to something that also was said, through these interactions, we're really generating the world. I was actually a Terry Winograd student, and you can see in this that this is something that comes from his idea of kind of like defining the interactions by doing them. So some of what we're doing in the autonomous car space is generating data. We're collecting a lot of data of people who are on manual drives and also autonomous drives, capturing all the things that are happening in the world, capturing what's happening with the driver, and understanding how these things are correlated. We're not only looking for like visual events, we're also measuring physiological measures and things like using automatic motion coding to capture facial action units. This is kind of what Barry calls this domain relationship with AI. Like this is something where we can actually capture data because we're good at talking to people and we know how to set up the cars. And from this, we can actually like look at physiological responses. Like we pick the courses that people drive. In this case, this is a drive from Stanford University up to Skyline. And for people who are familiar with the area, the only way that you can actually get up there is through these like mountain roads, which have like a lot of hairpin turns. So you can actually see the changing stress levels that people face, which get bigger and bigger as people get into the hills here. And this actually makes it so that we can actually correlate difficult road conditions with physiological response and use that for machine learning. I'm going to show this last piece was just shown at CHI a month ago, which is work by my PhD student David Goodkey, where we're pushing the boundaries of the theater even further by using VR with on-road driving simulation.
Does this feel like kind of okay?
Yeah, like, does it feel like I'm in a car?
Yeah.
Yeah.
All right. Can you put your hands out forward?
Yeah.
Right.
Ooh.
And just leave them kind of center in your vision. And now you can just like if you drive straight, you
Sure.
should be going just.
Oh, this is fucking weird. I should probably not drop the F-bomb.
Well, now we have a car coming in off the right. There's no real car
Oh,
in the real
God.
world.
Oh god.
You just. It was funny. Like there was a car hitting them in VR.
Oh, really?
Yeah.
Oh god.
There
Now
was-
we drove off the world.
Yeah. No.
Okay.
So one thing that's not obvious until you start to do it is that autonomous driving scenarios actually make the really high immersion simulations break down, because if you don't have the motion and you're attending to something other than the theater, you actually stop feeling like you're in a car. So this VR in the car experiment makes it possible to look at autonomous driving where you have all the physics of the real world, but then you can actually have scripted events, like in a driving simulator, so you can better anticipate how people are going to respond in different situations and look at takeover scenarios with that. So to generalize, I think theater has the power to give us alternative realities, different futures, and insight into what's actually going on in our presence, things that we're doing that we don't know that we're doing, but that are going to be important to know as we start to design for these situations. And I think of this as world sourcing. You know, we're really looking to the world to both get all the different ways that people might interact and then like learn from people what the contingent interaction should be like, and using that to design the futures that we want to have with autonomous systems. All right, and with that, I will do another plug for my book, which has now been out for a few years, but it talks about some of the theoretical underpinnings for this work.
Thank you, Wendy. We have time for a few questions. Questions? If not, I'll get started. So really fascinating work. I was thinking a lot of the examples we've seen in the earlier talks today are dealing more in the space of screens and kind of more online information systems. Do you think there are critical differences for taking the theater metaphor in those spaces rather than the physical kind of more?
I think that a lot of the techniques I'm talking about start up in that space. Like, for example, the Lumiere project that I pointed out, Clippy, starts with, obviously, is a classic work in the space of interface design. I just think that one of the reasons why this kind of technique will be more important as we start to move into robotics and stuff that's happening in the real world, is that the context is not, like one of the things about the internet and like little screens is that your context is really bounded. Though people might be all over the place in the world, in some ways you define the context by what's on the screen. Whereas when we actually start to have like robots and autonomous cars, those machines are in our physical world, they're existing in the space of our existing norms, and all the different noisy things that happen are going to be important. And so then I think these techniques become more important to use, because it's very difficult to just put up gates and keep anything from changing outside of our control.
Questions? There's one over.
I like the idea of the simulator, and I think we, as you said, we have seen it in the automotive and also in the automotive conference. It has been discussed a lot. Why is it so hard to do it in other areas? Because I would guess a simulator for a living room, a simulator for an office is so much easier than a driving simulator. What is your take? And I think so my take is you don't get it published, because I think we saw simulator work getting published. We basically had to create a conference to get it published. So because HCI guys don't like that. So what is your take? What could we do to use the power of simulation to get more innovative work really evaluated in Kai?
Yeah, I want to say, and this is speculation too, because I'm not totally sure, what's in the minds of the community. I think that the emphasis on controlled experiments means that like what you really want if you're going to do some sort of like deployment is to find out what everyone really does, and there's always a concern that if you run a simulator that it won't represent reality. I think what AI brings up is a new standard for how we might actually, what we care about, which is, like I was saying, the range of possible response. And in that case, all the noisy things that happen in the world and all the things that you can't control well are actually really important. They're not just like problems that you have to explain away or caveats, but they're in fact desirable aspects of our interaction run. And I think that is something that will help to kind of make simulation a little bit more palatable. I think the other thing is that design has not a really firm place in the HCI world, less firm than I would like. And I think simulation is part of that kind of design process that is not terribly well respected yet.
Looks like we have a question from Barry.
Yeah, I don't like simulator stuff, so but we'll have that conversation over a drink. Yeah, it's me. Actually, the one case I would say, you might be right, there's not enough simulator stuff in general HCI, but oh man, there's too much simulator stuff in driving. But my point's not about that. I wanted to say, I just really like the symmetry in your talk between the implicit stuff, which is about cases where you've got a transition from the person to the machine, and like we said, it's just still really difficult to do, actually, like wizards and all that. Yeah. And then the driving stuff, which is, of course, transitioning the other way. And again, and I just wondered, are you hopeful? Because we've been trying to do it one way for a long time and haven't really managed to pull it off. So are we going to pull it off for driving?
What are you...
Being able to do this transition between
automation and manual?
And manual. I mean, maybe it's just too hard.
Am I hopeful? I mean, there is actually a lot of success in the past, but if you look at flight automation, but the people in flight automation have been trained, and in fact, even selected to be very similar and then trained and retrained every couple of years in order to interact with automation. On the other hand, as I alluded to, we really haven't tried the design solution. Basically, if you look at the history of automation, we basically make the automation and then we train people to deal with it. And one of the things that's interesting about this current doing stuff in the cars is all we can do to train people to drive. It's not impossible to train people, but it's much more challenging than many people driving. It's actually maybe the first opportunity we have to try to solve the problems between human automation through design, which is actually making the machine work better. So I actually think there's just so many things that are untried and so many things that are interesting possibilities to help people like learn on the job and, you know, for the system to do a better job communicating what it's doing, that, you know, I don't know if I'm hopeful, but I think that there's a lot of things that we should do before we just call it a day and say it's not going to happen. Which, I mean, like, there are people like who work in this space who are also experts, like the people who, at Waymo, who basically have just already dismissed people being able to be involved just completely.
And while our final speaker sets up, there's time for one more question.
Hey, Wendy.
All right, thank you.
Oh,
is there another question?
Yeah.
Oh, yeah, hi.
Hey, Wendy. My name is Tina Zhu from KDH, and I have read your thesis about implicit interaction. It's a long time ago, and at that time, AI is not that popular. And I have a question that right now you will publish your book, and what do you think of the implicit interaction nowadays in AI context?
Well, I think that when you're interacting with any other system which isn't under your direct control, implicit interaction is going to be really important because the attentional demands of explicit interaction are too great. So I anticipate, especially with Internet of Things and AI, that this will become more prevalent and important. Thanks.
Let's thank Wendy one more time.
So,
I guess, yeah, now on the stage.